If someone told you that Tesla is spending up to $25 billion this year building new facilities, your first thought would probably be more cars, more Model Ys rolling off assembly lines, more Cybertrucks heading to dealerships, more electric vehicles flooding the American market. That would be a perfectly reasonable assumption. It would also be almost entirely wrong. Because when you actually follow the money, when you look at what Tesla is constructing right now across Texas, Nevada, and California, a very different picture starts to emerge. And once you see it, you cannot unsee it. Tesla became one of the most valuable companies in American history by doing one thing: convincing the world that electric cars were the future. The Model S made believers out of skeptics. The Model 3 made EVs accessible to middle-class families. The Model Y became the best-selling car on the planet. For most people, Tesla and electric vehicles are essentially synonymous. So when headlines announce that Tesla is building 6 new major facilities in 2026, with a capital expenditure that has jumped 135% from the previous year, the natural conclusion is obvious. They are building more car factories. They are scaling up production to meet demand. They are doubling down on the business that made them famous. Except that is not what is happening. Not even close. Here is the number that changes everything. Out of 6 major facilities that Tesla is either building or repurposing right now, only one produces a passenger vehicle. Just one. The other 5 are dedicated to energy storage, humanoid robots, artificial intelligence infrastructure, battery materials, and commercial transportation. 5 out of 6 facilities have little or nothing to do with the product that put Tesla on the map. That is not a minor shift in strategy. That is a company quietly preparing for a completely different future while most of the world is still talking about its cars. So what is actually being built? Let us walk through it, because the pattern only becomes clear when you see all 6 pieces together. The first facility is a lithium refinery in Robstown, near Corpus Christi, Texas. It became operational in January of 2026, and Elon Musk announced it himself on social media with a simple declaration: "The largest lithium refinery in America is now operational." This facility does not assemble cars. It does not make motors or batteries for vehicles. It processes raw lithium into battery-grade lithium hydroxide, the chemical compound that goes into energy storage systems. This is upstream industrial chemistry, the kind of infrastructure that commodity producers and mining conglomerates build. It is not what people picture when they think of a car company. The second facility is a lithium iron phosphate battery factory inside Giga, Nevada, Tesla's sprawling complex near Sparks. Production began in 2025. These are not the batteries that go into a Model Y or a Cybertruck. Lithium iron phosphate chemistry is used almost exclusively in Tesla's Megapack product, a massive industrial energy storage unit the size of a shipping container. The Megapack is sold to utility companies, solar farms, and grid operators. It has nothing to do with consumer vehicles. It is an industrial product for industrial customers, and Tesla is now manufacturing its own cells for it at scale in Nevada. The third facility is the Brookshire Megafactory, under active construction near Houston, Texas. This one is significant enough that it deserves a moment of context. The planned annual output of this single facility is 50 gigawatt-hours of Megapack storage capacity. To put that in terms that actually mean something, the entire existing Megapack manufacturing capacity that Tesla has built across California and Shanghai is around 80 gigawatt-hours. Brookshire alone will add more than 60% of that total once operational. This is not a supplemental facility. This is a massive bet on energy storage becoming one of the most important businesses Tesla operates. Hiring has already begun. The scale of this investment signals genuine long-term commitment, not experimentation. The fourth facility is a Tesla semi-factory, also located at Giga, Nevada, where ground was broken in 2024. The Semi is an electric truck designed for commercial freight, the kind of vehicle that hauls goods across the country. It is not a passenger car. It is not targeted at the consumer who walks into a showroom. It is targeted at logistics companies, freight operators, and large corporations managing fleet expenses. This is commercial transportation, a sector with entirely different customers, different sales cycles, and different economics than the consumer EV market. Tesla is moving into territory that has traditionally belonged to Freightliner, Kenworth, and Peterbilt. The fifth facility is not a new building at all. It is a transformation. The Fremont factory in California, the original home of Tesla vehicle production, is being partially repurposed. The lines that used to build the Model S and Model X are being converted. What will those lines produce instead? Optimus, Tesla's humanoid robot. In January of 2026, Elon Musk stood in front of an audience in Davos and said something that most headlines treated as science fiction, but that Tesla's capital allocation confirms as a serious operational priority. He said Tesla will convert the Fremont electric vehicle factory into a robot factory to produce 1 million humanoid robots annually. 1 million per year. That is not a product announcement. That is an industrial production target at a scale that would make Fremont one of the largest humanoid robot factories ever built by an enormous margin. The sixth facility is less visible, but arguably the most strategically important of all. It is called Cortex-2, and it is Tesla's artificial intelligence computing infrastructure, currently being expanded to 500 megawatts of capacity by mid-2026. The cluster runs on more than 130,000 H100 equivalent graphics processing units. For context, that level of computing infrastructure is what major technology companies, national laboratories, and government defense programs build. It is the kind of hardware investment that does not make sense for a car company. It makes complete sense for a company that is training autonomous driving systems and teaching humanoid robots how to navigate and interact with the physical world. Now step back and look at what those 6 projects have in common. A lithium refinery, a battery factory for grid storage, a megafactory for industrial energy systems, a commercial truck facility, a robot factory, a supercomputing cluster. These are not the investments of a company that sees its future primarily in selling passenger vehicles to American families. These are the investments of a company that is building the supply chain, the manufacturing capacity, and the computational infrastructure for multiple entirely different businesses simultaneously. And the timing matters. Tesla is making this investment in 2026, a moment when its core vehicle business is under real pressure. Automotive gross margins have been squeezed. Price cuts have been frequent. Competition from Chinese manufacturers, particularly BYD, has intensified globally. Here is the question worth sitting with. Why would a company facing competitive pressure in its core business choose this moment to spend $20 to $25 billion, most of it on things that are not that core business? There are 2 ways to read it. The first reading is that Tesla's leadership genuinely believes the energy, robotics, and AI businesses will grow large enough to offset or eventually exceed the vehicle business. The evidence for this reading is substantial. Megapack deployments grew 49% year over year in 2025. The energy division is already profitable. Grid-scale storage is a market that is expanding rapidly as solar and wind power require more backup capacity. If Tesla can dominate that market with vertically integrated manufacturing, From lithium processing to finished megapack units, the economics are potentially enormous. The second reading is more cautious. Robotics and AI infrastructure are extraordinary bets. The Optimus robot does not yet exist at commercial scale. 1 million units per year is a goal that has never been achieved by any humanoid robotics program in history. The timeline is aggressive, the engineering challenges are real, and the market for humanoid robots at consumer or industrial scale is still largely theoretical. Cortex-2 is a massive computing investment, but computing infrastructure only generates returns if the models trained on it produce products that customers actually pay for. These are not guaranteed outcomes. They are ambitious projections backed by genuine capital commitment, which makes them serious but not certain. And this is where the story gets genuinely interesting for anyone watching the American technology and industrial landscape. Tesla is not behaving like a car company defending market share. It is behaving like a company that has decided its long-term survival requires it to become something else, while also remaining in the vehicle business. The lithium refinery, the battery factories, the megafactories, the robot lines, the supercomputing cluster. These are the foundational pieces of what could become an entirely different kind of company. Not just an automaker, an energy infrastructure provider, a robotics manufacturer, an AI systems company, a logistics technology developer, all of these simultaneously, all built on the same underlying capability: the ability to build and deploy large-scale battery and computing systems more efficiently than anyone else. Here is the question that should be sitting in the back of your mind right now. Do you think this works? Because the answer is genuinely unclear, and anyone who tells you otherwise with certainty is selling you something. The bull case is real. Tesla has done things that experts said were impossible before, from making electric cars desirable to building the largest private charging network in America. The bear case is also real. Scaling humanoid robots to 1 million units per year while simultaneously building out grid storage and AI infrastructure and commercial trucks, all at the same time, is an almost incomprehensible operational challenge. Leave your answer in the comments because this is exactly the kind of debate that deserves more than a hot take. What is not debatable is the data in front of us. Tesla's capital expenditure has more than doubled in 1 year. 5 of its 6 new facilities serve businesses other than passenger vehicles. The Fremont factory, the physical birthplace of Tesla's automobile legacy, is being converted to build robots. The most surprising thing about Tesla's expansion in 2026 is not the money. It is what the money reveals. Most people, when they hear the name Tesla, still picture a car. But when you follow where the company is actually putting its capital, a different picture emerges. Whether Tesla succeeds or fails at this transformation, these 6 projects make one thing undeniable. The company is preparing for a future that looks very different from the one that made it famous. And if you want to understand what that future looks like before it arrives in your driveway, your utility bill, or your industry, stick around. We will be watching every step of it.